Hi, I'm Guo Cheng Guang, 5 from YUMIN Primary School.
My name is Guo Cheng Guang, 8 years old, Primary 2, also from YUMIN Primary School.
This lesson is Calculus. Chapter 4. Further differentiation. We'll continue with the L'Hopital's rule. Right now we have 4 questions. We will only use 2 methods for the first, okay? Okay?
Okay.
So can you write down what form are all of these, okay? So let me start with the first question. Limit z approaches to 1 plus I, and this 1 plus I minus z over square root 1 plus I minus square root z. Okay? Okay?
Okay.
So, let's start with the first method. Okay, so first method is the factorization.
Factor. Always Lopital's rule.
Okay, factorization. We have this limit z approaches to 1 plus I, then this 1 plus I minus z. So this splits. This is square root 1 plus I minus z times square root 1 plus I
Wait.
plus square root z.
Yes.
Okay, so then this over square root 1 plus I minus square root z. So we'll sub in, right?
Yes.
So this is actually 2 square root 1 plus I. But I cannot have I in a square root, right?
Yes.
So we'll need to continue. And did you know that we can actually write this as 2 over 2 plus 2 over 2i? Because that 2 over 2 is a 1, right?
Yes.
And then 2 over 2i is still an I, right?
Yes.
And later I will tell you why we take 2 over 2 and not other fractions. Okay? So we'll first proceed on, and then later I'll show you the magic.
The magic later we're going to begin.
So first, we know that this is a 2 over 2 plus, well, can we have a square root 2 here?
Okay.
And here is the square root 2 over 2 plus square root 2 over 2. Alright. So this is where the magic begins. So, because that, okay, let me test you. Sine and cosine. When are both the same? Sine and cosine.
45 degrees.
We don't say it like that. Pi over
8.
4, to be exact. It's pi over 4, okay?
Okay.
So this pi over 4 is when both are the same. And what is the result?
Square root 2 over 2.
Yes, square root 2 over 2. Wait a second. Isn't it these two?
Yes.
Right? So this is 2 square root. This is the square root 2. But remember, here there is this is a cosine. Very obvious, right? And here is a sine.
Yes.
Why? Why is it like that? Because that we're going to use the Euler's formula. Okay?
Oi.
So, with the Euler's formula, okay, let's look here. So this is actually e to the power of something, right?
Yes.
E to the power of only can be pi over 4i, correct? Because yet like this is only the way to be the same. But we haven't finished yet, right?
Yes, the Euler's
And this is
formula.
this square root 2, take it out. So square root 2, take it out, this becomes 2 5 over 4. Then another square root.
Yes.
Or can we just write here e to the power of something?
Yes.
Because like this is to the power of half times in pi over 8. This can be one of the results. But this is the Euler's formula.
Now the model.
Wait. Remember, this is the Euler's formula, the result.
Okay.
Okay, let me show you another.
The models.
Okay?
The Euler's
Like this. So, okay, let me write this. Okay, theorem spelled only. So the Moivers. Okay, let me show you how to spell theorem. The O
Yes. Oh,
theorem.
wait.
Is it?
Okay.
The Moivers theorem. Okay? This part is actually a person's name, okay?
Yes, the models.
Okay, so but can you write out something?
Double.
Okay, double angle formula, because we'll be needing it as there is this cosine, there is this sine. Okay?
Okay.
You need to write it out.
What 3 cases?
Okay, yes, 3 cases.
Which 3?
So the 3 cases, it's just the 3, okay? Wait, is it the cosine squared this thing, alpha,
Yes.
minus the sine squared alpha? Is it? So another case is when we change the cosine square, right?
Yes.
We change the cosine square. Cosine square, change it. So when we change it, it becomes I don't need you to write it out. It's very simple. It's just a 1 minus sine square. This is not a D. This is an alpha.
Yeah.
But that's not a D. Okay, never mind. There's the 2. You must write that 2. Okay, so it's the 2 cosine square alpha minus 1. Cosine square alpha minus 1. Okay?
Okay.
So next there's one more case whereas there is a 1 plus or minus 1. Plus or minus minus 1 minus the 2 sine square alpha. Okay?
Okay.
So can you write out what is cosine alpha and sine alpha? You will need to write out both. So sine alpha, positive, negative, square root 1 Plus or minus? Yes, correct. It's a minus, but minus what? Is it a cosine 2? Are you sure? Okay, yes, it's actually yes. Next is for the cosine.
The title plus.
Okay, yeah, correct. Yes, okay. So, we need to use it here, right? This is 2 to the power of 5 over 4. Then here is this. Okay, so we'll use this positive one, right? Both positive,
Yes.
correct?
In this case, we use positive.
So for this positive, this is the square root. Okay, let's find the cosine first. So this is 1 plus. Wait. There's this cosine
Pi over 4
pi over 4 over
2
2 plus
plus square root.
I square root.
Okay, so I square root.
But this is not the I root, okay? It's I times the square root.
Okay, I square root 1 minus cosine pi over 4 over 2.
So, in a bracket, right?
Yes.
For this is the square root 2 over 2. Am I right?
Yes.
So let's put this, leave it here first. But can we take out the square root 2 out? But remember, this is actually a square root 1 over 2. Okay? So it'll minus. So when you minus, it minus half. And half is 2 quarters. So it's left with 3 quarters. So for this is the square root 1
Okay.
plus 1 plus, tell me,
1 plus square root 2.
over 2, right? Because that's a cosine.
Then plus I
Okay, also can
square root 1 plus
minus
1 minus square root 2 over 2.
like this. What happens? What happens? Can we? Okay, what can we have? Take out another square root 2.
Okay.
So this becomes 2, 1 over 4. Okay, but what happens to that? Would it be like square root 2? But what about the 1? Plus?
Yes.
Wait, I think it is not right. Oh, times. Here's the times, right? Times
Times 2.
times
Times
square root 2
square root 2 plus 1.
plus
I square root 2 times square root 2 minus 1.
is it?
End of bracket.
Yes. But up here, is there anything? No, right?
Yes.
Can we continue?
Yeah.
Wait.
Two to the power of half.
2 to the power of half. Wait, this part?
No.
Oh, the next step, right? So we'll have to find a. Oh, so it's just square root 2, right?
Yes.
So we take out all of the square root 2, add back. So this is the square root. Okay, no more this kind of bracket. Then this is the square root 2 plus 1 plus I times square root 2 minus 1. Is it like this?
Yes.
Okay, so
Now we'll use the loop.
so this is the answer, right? So okay, now we'll use the L'Hopital's rule. Can you write it below? Can you write it? And can use it. Okay? And just one hint I want to tell. Usually, L'Hopital's rule, would it be easier or harder?
Easier.
Okay, so easier, right? Use it. So if it is easier, most of the time we'll use it, right? But except some other times when, okay, continue. When it actually becomes extremely difficult.
Or can
Or-
I solve
Yes, very good.
like do not exist?
Yes, correct. Okay? So we'll need to see what case are we dealing with. Okay?
Okay.
Start. Okay, so it's actually, we're looking at z, right? So that z, this is a negative 1 up here. Yeah, negative 1 over this negative square root z. There's still the negative. Is it a 1 over something?
No.
1 over something. 1 over 2. Okay, never mind. I'll write this. Like this. Then 2 square root z flips to the top. And then this is 2 square root 1 plus I. We're facing the same problem again. So we look at up here. This is what happens. So actually the same thing happens again, right? Okay, so you don't need to continue because that we already know that it is the exact same thing, right? Because we don't have any other methods. Okay, so this is for question 1. Can we go on with the other 3 questions?
Okay.
Okay, so let's erase. Okay, so I will continue with the other. The second question, we'll only need to use one method for the rest, okay? So erase it. Okay, the second question, only using the L'Hopital's rule. And this is infinity times 0. So what if we actually write it as, okay, let's look at this. X over e to the power of x.
Okay.
Then differentiate. Limit x approaches to positive infinity. This is 1 over e to the power of x remains the same.
Yes, the one over infinity, which is 0.
0. Short, right? Very short, right?
Yes, but the next one is not that short.
So let's move on to the third. So this is limit x approaches to positive infinity, x to the power of 5, e to the power of negative square root x. So this is the limit x approaches to positive infinity, So this, we can write it as x to the power of 5. All of this over. So negative square root x. This one we can write it as e to the power of square root x, right? Because that negative means at the denominator. Like this. X to the power of 5. So we keep differentiate, right?
Yes.
So this limit x to the power of, x approaches to positive infinity. This is 5x to the power of 4 over e to the power of square root x over 2 square root x. This thing flips to the top. So here we get a 10, right?
Okay.
There's this 10 and this x to the power of, remember here's one more. This thing flips to the top. This is the half, right? So
Okay.
is this a 9 half?
Okay.
Then this over e to the power of square root x.
The limit x approaches to positive infinity. 10 times 9 x to the
10
power
times?
9.
Are you sure it's 9?
Yes.
9 half.
9 half.
Then we already know that here times the 2, right? Times
Yes.
the 2. This is an x to the power of, okay, let's see first. This is a 7 over 2. Then 7 over 2, here's another, becomes
It becomes 8 over 2.
over same thing.
Okay.
But did you realize this pattern? Did you realize it? This
Yes.
at first is just this 10.
10,
10 times 9.
10, 9,
And can you guess what is the next?
7,
Okay, 8 and 7, right? So let's find out.
then 6,
Then if we found the pattern, we can dot dot dot. Last 2, okay?
then 6, then 5, then 4, then 3, then 2, then 1.
So 10 times 9 times 8 over 2. 2 goes up. This is the x to the power of, this becomes a 6 over 2 plus 1, 7 over 2. Okay?
Okay.
There is e to the power of square root x. Cancel? Yes, it is that pattern, right?
Okay.
So let's dot dot dot, okay? So that means it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all these times together, right?
Yes, then it will be 10 factorial.
So this limit x approaches to positive infinity. So this is a 10 times 9 times 8 times 7 times dot 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 times all the way. Let's see until 2. So here it is 2 over 2, right?
Yes.
But we don't put as 1. Am I right?
Number 2.
Okay, so bring it down, okay?
Okay. And then what
So
about
let's
number
bring
2?
it down times 2 over 2 times, then this 2 goes up. Then this is, at first it becomes the 0, then plus 1 more. Half, right? So then this is just e to the power of square root x. Cancel. Yeah, 3, 2, right? The next is finally the 1. For the 1 is actually 10 factorial, right?
Okay.
Because it's like that. As 10 factorial, don't read this as exclamation mark. It's not. Okay?
That means 10 times.
Exclamation mark is only in English. This is mathematics. We call it factorial. So this is
10 times 9 times 8 times 7 times 6
dot 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 No more, right? This x. Because that minus 2 becomes a negative, but you plus that one more, 0.
Okay. And just don't calculate the 10 factorial.
So let's look at this. This is actually a whole number, right?
Yes.
It is fixed, a fixed number. But this is an infinity. A fixed number over an infinity is 0.
Okay. It's okay.
Okay, so next is the fourth question. Fourth question. Here, just make a guess. Something like in science, the hypothesis. First guess. Try. What would you think the answer will be?
The answer
Yeah.
still 0.
Okay, you make that guess. So let's find out, okay? So this is limit x approaches to positive infinity. And this, wait, I just copied this.
Why did you copy the wrong name?
It's a 5, right?
Okay.
Remember, still using the L'Hopital's rule. Okay?
Okay.
This is limit x approaches to positive infinity. Then, remember this as x to the power of 5 over 3 over e? No, right?
Yeah. Yes.
Wait, no, not 3 over 4.
Yes.
3 over e. This is, because at first it becomes a negative, now reciprocal becomes a positive. Like this, right?
Yes.
Can we write it in any other ways? Like, okay, let me test you.
I know the numerator is the
A.
same.
Where is your limit? So a to the power of x. What can this be? Okay, so e to the power of x ln a. So let's write this as that form. E to the power of, what is the x? Square root x, right? Ln a. Ln a, what is it? 3 over e, right?
3.
Ln 3 over e. Wait,
No,
but
4.
but remember, okay, let's just calculate over here. Ln
3.
3 over e.
Therefore,
Oh, what is here right here? So this is 3 over e, right?
yes.
But did you remember the special thing?
Special.
Ln 3
Ln 3 minus
ln
ln
e.
e,
Is it?
which is ln 3 minus 1.
Yes, correct.
Okay.
So we'll put this as ln 3 minus 1. Bracket, right?
Yes. And in front still got.
Why?
Okay.
So here there is this limit x approaches to positive infinity. Okay, let's start the differentiation. Okay?
Okay.
So this is the 5 x to the power of 4, right?
Yes.
But don't forget this square root x flips up times 2. Then this becomes 9 over 2, right?
Yes.
And this over, this thing bring down, doesn't change at all, right?
Yes.
Then times,
Times ln 3 minus 1.
I
Why?
already wrote it here. It is right. Is it?
Yes.
Okay, so for this, there is this another limit x approaches to a positive infinity. this time we'll bring this down. So 10 times 9 over 2 times another 2 goes up. 2 x to the power of 8 over 2, right?
Okay.
Because at first this becomes the 7 plus 1 more becomes an 8. Okay? But this, because it doesn't change over here, and yet you only need one more. So this is a ln 3 minus 1 square. Then
So e to the power of same thing.
okay, it's the same, right?
Yes. The denominator will be the same.
So like this. Simplify. Then can we just write dot 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 because it's all the same, right?
Yes.
As the pattern is the same, but the question is different. So then this all the way. Okay, let's check the second last. So this is 10 times 9 times 8 times 7 times dot dot dot. Wait, this is not minus. Times all the way until 3 times 2. So this is x to the power of half. Then at first this was actually a 2 over 2.
Yes.
Then times 2.
So you simplify.
Yeah, simplify. Okay, let me just write this whole. 2 over 2 times, you write? Faster, x to the power of
x to the power of 1.
faster.
So this to simplify.
So guess what is this? How many numbers are there? I'm gonna ask you.
There is
10 to all the way to 2. So
There
there's
is-
9 numbers, right? Because
Yes.
then after you add a 1 is 10. So here is 9 to the power of 9. To the power of 9. Okay. Then limit okay, quickly, yes, 10 factorial, then the things below. Well, next time don't extend this way. Ln 3 minus 1, yes, to the power of 10, e to the power of square root x, bracket, ln 3 minus 1, bracket. So what is this? Okay, I want to ask you, is this a whole number?
Yeah.
It's a number, right?
X.
So a number over a number times infinity. So that means it's a number over infinity. So that means it's a
0.
yes. Okay, so do you understand?
Okay.
And this will be the end. Okay?
Okay.
Bye.